Okay, Geometry AB, we left off about halfway through 10.6 yesterday, so we're going to pick it up right here, talking about adjacent arcs. And that word adjacent, everybody, is one that we've used during the course of the year. It basically just means two things that are right next to each other. So when we talk about two arcs that are adjacent, it's going to be two arcs that do not overlap, that share a common endpoint. So if we were going to draw ourselves a circle, we need to identify probably at least 3 points here to illustrate adjacent arcs. So there's going to be A, and here's going to be point B, and then we'll put a point C right next to that. And if we took a look here, we have one minor arc here that goes from A to B, and another minor arc that goes from B to C. And that would be an example of two arcs that would be adjacent to one another right here. So adjacent arcs would be something like AB and arc BC. They share a common endpoint, which is right here at B, and they don't overlap at all. And the arc addition postulate works exactly the same, really, as the segment addition postulate and the angle addition postulate that we learned earlier in the year. That if we were to take the measure of arc AB, which is a measure is going to be done in degrees, and add to that the measure of an adjacent arc to it, which in this case might be arc BC, adding those two measures together is going to get us the measure then of the large arc AC that they make together. So, kind of like we did before with little angle plus little angle equals big angle, here now we're talking about little arc plus little arc is equal to a big arc. Fairly simple concept here. So, let's see that illustrated in an example right here. Okay, so what we are allowed to assume from this diagram is that a point that appears to be at the center of a circle is in fact the center. And what we have right here are 1, 2, 3 points on the circle identified and radii drawn to all three. We've been given the measure of this arc and this arc. What we don't know is the measure of this arc right out here. But, given what we talked about yesterday, we know that if the measure of a central angle is known, then the measure of the arc that it intercepts is going to be exactly the same size. Well, that corner mark tells us that this is a 90-degree central angle, which means that we have ourselves a 90-degree arc right there. And putting everything together now, we know the measure of that arc is 11x plus 17, this arc is 9x minus 47, and this arc here is 90. Together, those three arcs make up the entire circle, so we're going to go ahead and use the arc addition postulate and add them all together. 11x plus 17 added to a 9x minus 47 added to the third arc, which is 90, has to be a total of 360 degrees. Mr. Fontana made-up word here is circumference. It's not a real word, but complementary we talked about this year, meaning adds up to 90. Supplementary means that it adds up to 180, and my made-up word of circumference means that it has to add up to 360. Okay, let's combine some like terms here. 11x and 9x are going to combine to make a 20x. We've got a 17 minus a 47, which is going to make a negative 30, plus 90 is going to be a positive 60, equals 360. We're going to subtract 60 from both sides and get 20x is equal to 300, and then divide both sides by 20 and get x is equal to 15. And we could plug that back in and check it out. Everything would add up to 360. I'll let you do that on your own. Okay, circumference of a circle is a topic that I always think geometry students have seen before, but it seems more and more people are coming to me saying, no, we haven't really covered that before. So the first thing we better do is talk about what that word circumference means. And the word circumference is very similar to the word perimeter. The difference being that perimeter applies to a polygon, something made up of line segments. So our definition of circumference is the distance around the outside of a circle. The distance around a circle. So if we were going to draw a circle, okay, and think about actually starting at a particular point right here and walking all the way around that circle and making one complete lap, the circumference would be measuring how far you've actually walked to go around that circle. And the formula for circumference, there's one formula, but it really goes by two different forms. The more common one is that circumference is equal to 2 times the magical number of pi times r, which is the radius of your circle. So circumference equals 2 pi r. Or the other version of that formula, although it's really the same, would be that circumference is equal to, well, 2 times the radius of a circle is going to get you its diameter. So pi times d, where d is the diameter, is another way to measure the circumference of a circle. Now, what we should probably make a note of right here, what I think a lot of you guys know already, is that the number pi is kind of important right here. And we know that pi is roughly equal to 3.14. As you guys have probably talked about a lot in other math classes as well, pi is not exactly 3.14. And where it came from was mathematicians all over the world, not just in ancient Greece, were kind of curious at what happened right here when they looked at the circumference of a circle, the distance around, as compared to the distance across, which is its diameter. And what they found is that in every single circle that they drew, when they took the circumference of that circle and divided it by its diameter, they always got the exact same ugly number of 3.14159, so on and so forth, forever and ever, amen. And no matter how big or how small the circle was, the ratio of the circle's circumference to its diameter was always equal to that same number. So people sometimes ask the question of where did pi come from and how did they know to use it in this formula, and that's really looking at it backwards. Pi actually came from direct measurement, and then mathematicians just looking for a pattern. And they found that no matter how many times they did this, that ratio of circumference divided by diameter was always equal to this magic number of 3.14159. Now it goes on forever. It's an ugly, irrational number. So that's when they decided to just use a symbol to denote that. And that's where pi, which is the Greek letter P, came from. It's important to realize that even though pi is a letter, we tend to use letters like, oh, this R or this D here to represent variables or unknowns. But pi is a constant. In every single problem that we ever do, pi always has this same value of 3.14. Now in middle school, they tend to ask you guys to approximate that value. And here at this level, we tend to keep things in terms of pi. So let's take a look at a couple of examples right here. First one we've been given a circle, and we've been given the radius of that circle is 23 inches, and we're asked to find the circumference. 3 steps as always, guys. Start with a formula, circumference equals, and since we know a radius, I'm going to use the radius version of the formula, 2 pi r. Step 2, fill in what we know. We don't know the circumference, but 2, we do not put 3.14 in for pi. We just leave it as pi, and our radius now is 23. And step 3, simplify and evaluate what you can. All we're going to do here, guys, is multiply the 2 times the 23 to get a 46, and we're just going to keep a pi at the end of that answer. The units are going to be inches, just like they were here, because circumference is a distance. So our answer right there is 46 pi inches. Now, back in middle school, you might have been asked to go to your calculator and then use the 3.14 button that you had right there in order to figure that out. So if we had done this back in the day, 3.14 multiplied by 46, in middle school you might have said that this answer was approximately equal to 144.44 inches. But at this level, we really prefer that right over there. Okay, so in fact, I'm even going to just get rid of that, and that's where we're going to quit it. Now let's take a look at B, and this is a good example of why high school problems are harder than middle school problems. We're supposed to find the radius of a circle, so different set of directions now. Find the radius of a circle with a circumference of 17 pi. Now lucky for us, the 3 steps are the same. We start with the formula, circumference is equal to 2 times pi times the radius. But in the last problem, we knew that the r was 23, and we were trying to find c. In this problem, we know the circumference is 17 pi, so that goes here under the c, and we're looking for r, so that's 2 times pi times the radius. And now from here, we are trying to get r by itself. So we look right here and see that r is being multiplied by 2 pi, so we're going to divide by 2 pi on both sides. And right here I've got to warn you guys about something important. Okay, those 2 pi's and those 2 pi's cancel, so we're going to end up with, here we go now, we're going to end up with r equals. Okay, and this little calculation right here looks simple, but it's very, very easy to do this wrong in your calculator. The most important thing to realize, everybody, is that with a pi as a factor on both the top and the bottom, these pi's simply cancel each other out. And all you really should be putting in your calculator is 17 divided by 2, which is going to get you 8.5 centimeters for your radius. But I'll warn you guys that if you simply go to your calculator and type in 17 pi divided by 2 pi, you're going to get an answer that's really, really wrong. Off the top of my head, it's going to be somewhere in the neighborhood of 75 or 80, if I'm not mistaken. If you're going to do it that way, you have got to remember to put parentheses around that 2 pi down there in the denominator. And if you can do that, you're going to get this right answer of 8.5. But honestly, the better thing to remember is that these pi's right here simply cancel out, and you should never even put the pi's in your calculator.